Good morning, everybody, and welcome back. This is a kind of one of the nice sessions for me is I get off pretty easy on this one because I've asked Jesús, my colleague, to come in and talk to you a little bit about extending the communications framework that we've built now to what I would classify as a much broader scoped type of enterprise-enabled architecture that allows you to leverage IoT at a much bigger and more global scale. So just to refresh kind of what we talked about, our typical disclaimer here, as we've always said, if we talk about any future-looking information, those things are subject to change, especially in our current climate. As I mentioned, my name is Bill McLane, and I've got my colleague Jesús with me to talk to you about our Project AIR solution. But just to give you a little bit of a refresher on what we've done up to this point. Specifically, we've taken and built out the actual architecture and the hardware that we are using to provide a very simple solution to a common problem, which is building out a sensor that's going to send ultrasonic data via Raspberry Pi via MQTT into whatever ecosystem we want through TIBCO messaging. So enabling that sensor to be able to leverage MQTT as a back-end framework for communications, and then using that framework for communications to extend that communications to TIBCO FTL or Kafka or Apache Pulsar or TIBCO Cloud Messaging is what we've worked on up to the last kind of 4 weeks as we've gone through this project. And that's great. That's really where the foundation of most IoT projects start, is how do I first understand what data do I need? Second, how do I enable that data to be available to the applications or processes I need? But then the next layer to that is really, what do I do with that data? How do I leverage that data appropriately, and how do I take that data and use it in a way that's going to become relevant to my business? And that's really where I wanted to bring in Jesús to talk to you a little bit about our Project AIR solution, mainly to talk to you about how Project AIR can really equip you for that next level of communication, doing things like device management. And so at this point, I'm going to turn it over to Jesús so he can kind of talk you through a little bit of the pieces of the puzzle with regards to Project AIR. So Jesús, over to you.
Excellent, excellent. Thank you, Bill. And thanks everybody again for your time today. So let me share my screen here and give you a 5-minute overview on Project AIR, right? And how basically it fits into that communication framework that Bill mentioned. So Project AIR is part of what we call here TIBCO Labs umbrella. Basically, it's a program for innovation, and Project AIR is one of the projects that we cover. The project allows you to basically register and interact with IoT devices, whether it's a gateway or a sensor or an edge device, and then it allows you to extract the data, process the data, and transport it to a final location, right? Whether it's a web application that is going to consume real-time that data via streaming, or whether it's data at rest and then use that data for analytics or historical trending or alerting, or even enabling ML for things like anomaly detection or preventive maintenance, right? So the range and the depth of the use cases is really, really wide. But think of Project AIR as that core component in your architecture that is going to allow you to basically move the data and interact with the edge and connect the edge to the enterprise. It follows an agnostic approach, so you can deploy this project in any cloud environment that you want. And more importantly, it allows you to own the data. So typically, in some of these implementations, especially more on the IoT side, depending on the provider that you work, you may or may not own the data. So in case that you want to do like historical trending or simply leverage the data with other data sources for machine learning purposes, then typically you have to pay a premium, or it gets complicated to get your hands on the data itself. So Project AIR allows you to keep that ownership on the data forever. And it allows you to extend it in every layer along the way. So we'll touch a little bit more on this last point in just a second. So just a quick, I guess, a snapshot in terms of the key capabilities that you should keep in mind when you think of Project AIR. The first one, as I mentioned, is the connection and extraction. It's going to allow you to do data management. It's going to allow you to also create triggers to respond in real time to IoT events. So this is a key differentiator. We're not talking about like reactive action on problems or maybe batch process-based analysis. Here we're talking about like real-time reacting to IoT events as they are being captured or identified. It allows you to as I mentioned on the top right corner, like transport the data to find a location, visualize it, explore it, build things like AI and ML models on top of it. And it comes with all the monitoring and tracking capabilities. So as things are detected, you can send back IoT commands to the sensors, so then you can take immediate action on a specific issue. So at the core of the project, there is a framework. It's an open source framework called HX Foundry. This is a framework from the Linux Foundation. And this is the framework that makes a lot of what I said really possible. So we leverage the API connectivity that the framework provides to interact with IoT gateways and basically transport data back into the enterprise. So let's go really quickly here through the architecture to understand then how everything ties. So in a classic IoT environment or picture, you would find sensors moving things, right? Like this could be trucks on the highway across the country or containers on a ship in the middle of the Atlantic Ocean with no connectivity. So it could be a wide range of scenarios, right? But think of whatever makes sense to your organization, right? Think of that IoT ecosystem that you have going on. The collection of all those sensors, they are typically going to interact with a gateway component of some sort. That connectivity may be over wireless, cellular connection, Wi-Fi, even things like Bluetooth for local connectivity. Typically, like if you're in a factory, for example, you have like the line of assembly, you're going to have like sensors all over the line, and they're going to be sending data that way. So whatever the setup it is, right, like that's going to be considered your edge side of the house, let's say. And for us, that gateway component is key, right? Because typically that's where you would find then the HX framework that I was talking about being installed. It's going to leverage the compute processing on that gateway component. And in combination with Flogo, TIBCO Flogo, basically this is how we tie to everything that Bill has been building for the last 3 weeks during these sessions. So leveraging, for example, the MQTT communication framework, then you establish that connectivity from the gateway into the IoT platform that we're building. That allows the transport of the data, the reading of the IoT events. It allows leveraging HX, allows the edge device registration, configuration, establishing business rules, alerts, and notification rules, and the device management capabilities. So as the data flows in, then the data continues to be streamed into the enterprise. Now, typically, there's going to be 2 types of scenarios. You're going to have the more, what I call the traditional one, where the data is going to be streamed into a data at rest endpoint or like end state. This could be your traditional database, right? Like in the case of TIBCO, for example, if you use, TIBCO product could be something like Graph database, for example, right? But it could be really anything. This could be on the cloud, could be on premise. It could even be like a hybrid scenario. You could have like a distributed environment and be sending data to different locations. Typically, at this point, that's when you're going to leverage, protocols such as Kafka, for example, to be streaming the data that way. Once the data lands and sits at rest, then you're going to have analytics, ML, AI. So in the case of TIBCO, you would use things like TIBCO Spotfire, TIBCO Data Science products to do that. And typically, then you're going to build some sort of application, right, to consume the data. So that is done usually, in the case of TIBCO, using TIBCO Cloud Live Apps. This allows you to, this allows you to integrate not just the feed from, let's say, something like Spotfire, but other data sources or other systems in your organization and have that single view on everything. Now, another sort of like swimming lane here in this diagram would be more like a real time feed. Basically, the processing of all those events that they are coming from IoT data. In the case of TIBCO, you use TIBCO Cloud Events to do that. And then as you process the data, you can consume the data via API. So typically you have an API gateway of some sort. In TIBCO, we call that product TIBCO Mashery. So you could use Mashery to do that consumption of the events via API and integrate that feed into your web applications. So you would use, for example, TIBCO Cloud Integration to do that. So now you have your web applications being basically the consolidation of everything, right? Like historical data from an analytics or a machine learning point of view. You have like your real-time feed coming from IoT events that are happening. And basically you have like an easy way to consume that. This could be over a web application on your mobile phone. So that's usually what you consider the enterprise side, right? And so Project AIR is, as I mentioned, that core component, it sits in the middle, is the platform that makes everything happen. And more importantly, right, like it's a platform that is going to allow you to have the back and forth. It's not just the extraction and transportation, but it's really that interactivity, being able to send IoT commands via something like REST API, for example, back to the gateway to take immediate action upon certain events. So hopefully this gives you a good idea in terms of how you can keep growing based on what you've been building for the last 3 weeks, right? Take that communication framework, use Project AIR, and take it to the next level. So in order to move forward with Project AIR, there's a couple of links that I want to mention really quickly. There's the GitHub site for Project AIR. That's the middle link here. The repository is it's open, it's free. You can explore it, download it, give it a shot. You can have like a local installation of Project AIR. You can do AWS or another cloud provider if you want as well. There's more information also on the TIBCO Labs page. And always you can join the community to interact with other members. If you have any questions on Project AIR, feel free to contact us and we'll be happy to hear from you. So that's all I have, Bill.
Great. Thank you, Jesus. As you guys can see, I mean, the reality of all of this is really taking all of that data and leveraging it and pushing that data into a framework that allows you to access it, to connect it, to unify it, and make it into something more than what it originally was. And that's what I think Project AIR really brings to the table is the ability to take those communications frameworks and really extend them into systems that now can do data analytics, AI, ML types of functionalities. So thank you so much, Jesus. Look out for some other projects that you might see that we're doing around IoT. One of the things you might be seeing coming up soon is some work that we're doing with Lego and some Lego train work that might be coming out with our users conference coming up here. So keep an eye out for those, and we look forward to talking to you all in the future.